Retrieving management information from remote computers. In this nugget, we're going to focus on Windows management instrumentation, which is a great way for getting management information from remote computers. We'll start with a brief introduction to WMI to sort of explain what it is and how it works. And I'm really going to get into how it works by exploring WMI, just kind of browsing around and knocking around in there and seeing what's in there. I'll also show you the documentation at that time. Now we'll experiment by using WMI just from the local machine, although we'll look at how to use WMI the exact same way pretty much to get information from a remote computer as well. And of course, because remote computers might care about you being an administrator, we'll look at how to specify alternate credentials for WMI connections. Finally, WMI is capable of returning an awful lot of data, and sometimes it's more data than you really want. So we'll also see how to filter the data that WMI gives you. So what is WMI? Well, it's a lot of acronyms. See, back in the beginning of time, this must have been back in the mid-90s, there was an industry group called the Desktop Management Task Force, or DMTF. These days, the D refers to Distributed Management Task Force. They kind of broadened their scope beyond just desktops. Microsoft was a member of this group, and the group's goal was to sort of come up with a vendor-neutral, industry-standard way of getting management information, distributed management information, from computers all around the enterprise, no matter who made those computers and no matter who made their operating system. One of the things they needed to do was come up with a way of representing management information, some kind of standardized way that everybody could agree on. So they came up with the Common Information Model, or CIM. And we're currently actually in version 2 of the CIM, so CIM v2. Each vendor then went off and implemented a way for the information on their operating system and computer platform to be represented in this CIMV way. Microsoft came up with something called Web-Based Enterprise Management. This was back in the days when IIS was the most wonderful thing ever, IIS 5.0, before it turned out to be a huge security problem by installing on it every single computer. So Microsoft kind of backed off of the web portion and decided to call something Windows Management Instrumentation. WMI is a means of retrieving management information from computers, representing that information in the Common Information Model in a way that's compliant with the practices outlined by the DMTF. WMI was primarily, in its initial days, designed to read information. So if you've got a computer out there, WMI was intended to pull information off the computer. Maybe it's service pack level, the number of processors it has, whether or not a particular program is installed. A little bit later, not too much later, Microsoft figured out that this was also a great way to push configuration changes, maybe reconfigure services or reboot the computer entirely. And so those are the sorts of things today that you can do with WMI. Now, Microsoft, as you probably know, is broken up into multiple different product groups. We've got the group of people that make Windows. There's another whole team that works on Exchange. There's another whole team that works on subcomponents of Windows, things like IIS. There's another whole group of people that works on SQL Server. Well, each of these groups was asked to expose whatever information made sense for their product in WMI. And the way they do that is by writing WMI providers. The Windows team wrote one, the Exchange team had one, IIS team made a really, really nice one that can really do a lot. The SQL Server team made one, and so forth. What this provider is designed to do is take information out of the product and expose it in that Common Information Model way. Microsoft's sort of standard technology, the generic WMI that sits at the top level, reads that information and makes it available to us through scripts, through commands, through Windows PowerShell. You may have used older command line utilities like wmic.exe, which runs under command.exe. PowerShell has WMI capabilities built in that are pretty similar to, although much better and much easier to use than, WMIC. Now, because all of this information could really get overwhelming, there needed to be a way to organize it. And so WMI is organized into a set of namespaces. Generally speaking, each namespace represents a particular product, like IIS or DNS or something like that, SQL Server, Active Directory, you name it. Within the namespace, there are one or more classes. And classes is something that's actually defined by that common information model. A class is some manageable component, maybe a disk drive or a CPU or an A record in a DNS server, or maybe a website in IIS. The class is really a description of what the manageable component is. A disk has free space, it has a total size, and you can defrag it. The CPU has a serial number and a speed, and you can't really do anything to it. A website has got all kinds of configuration information, and you can change that information. You can delete the website. The next level of management here is called an instance. And an instance represents some real-world occurrence of one of these classes. So for the disk class, you might have an instance for your A drive and one for your C drive. In a dual processor machine, you'll have an instance for processor 1 and an instance for processor 2. If your DNS server has 100 A records, then you'll have 100 instances of the A record class. If your IIS server has 2 websites, then you'll have 2 instances of the web class, whatever that class is. Now the namespace that we're primarily going to be working with is called root /CIM_v2. That's where most of the core Windows operating system stuff lives. So whether or not you're running Exchange or IIS or anything else doesn't matter. The fact that you're on Windows means this is kind of the lowest common denominator for us to discuss. However, you should know that all the techniques we're going to be looking at apply equally to any product which is using WMI. One of the things I don't like about WMI is the fact that it's kind of abstract. You know, it all feels very cerebral and philosophical. I want to look at it. I want to touch it. To do that, I'm going to need to download a tool. So I'm going to go to www.scriptinganswers.com again, and once again in the Tools zone, look for the WMI Explorer. There it is. So let's download this. I'm actually going to save this. Into a folder called CDemo, just so I know where it is. And the neat thing about this tool is you don't actually have to install it. It's just a standalone compiled little tool. You do need to be an administrator to run it. So just double click this. Yep, let's go ahead and run it. I start off in the root namespace. There's not very much interesting in the root namespace. In fact, everything you see has a double underscore. Anything in WMI that starts with a double underscore isn't really for you. It's a system thing. It's just how WMI keeps track of itself. Remember I told you that the namespace that contains all the core WMI stuff for the Windows operating system is root /CIM_v2. So let's click on that. There's a lot in here, so it's going to take the tool a moment to find it all and create the list. But if you look at these namespaces in the tree view, you can see that there's a lot of other stuff there. Active Directory, DNS, RSOP, service model, thin print, WMI, all kinds of things. It probably should go without saying, but let's say it anyway, that the WMI contents of any given computer depends on the products which are installed on that computer. I only have an Active Directory and DNS namespace because this computer is a domain controller that has DNS Server installed. You'll notice that I do not have a namespace for SQL Server because I don't have SQL Server installed. So you can definitely see differences in that tree view. If you're going to work with WMI, it pays to install this little tool or to copy this little tool over to the computer you plan to work with. That way you'll be able to see the WMI classes that computer has. All right, so let's explore this /CIM_v2. Lots of classes in here, and you'll find that the ones that are the most useful start with Win32_. Here's BIOS, for example. If I click on that, I can see its properties, BIOS characteristics, BIOS version, build number, caption, current language, all sorts of cool stuff. And I can see if there are any methods. There aren't. That means I can't do anything with the BIOS. Let's go look for the core operating system class. It's called Win32 Operating System. It has some methods. I can ask WMI to reboot, shut down, or change the date and time. It's got some nice properties too, including the build number, the boot type, the description of it, free physical memory, free virtual memory, the manufacturer, number of licenses, number of processors, service pack major version and service pack minor version right there. Really good information coming out of here. These are all just descriptions of the class though. I'm not actually seeing the service pack major version for this computer. To do that, I need to look at the actual occurrences of this class, the instances. Well, there's only one operating system on my computer, so I guess it makes sense that I only have one instance. Here I can see that the build number is 6001 and that the service pack major version is 1. Service pack minor version is 0. Let's go to Win32. How about Win32 partition? That would be under P. Oh, nope, nothing for partition. And that's why having a Explorer tool like this is useful. If you don't find what you're looking for the first time, think about what else it might be called. How about disk? Scroll over to the D's. We'll stick in Win32 and we'll look for, here we go, disk drive. Now that's not exactly what I want. Disk partition, that's what they named it. Okay, so if you explore around in here, you can usually find what you need. If I click on this, I see that I've got one partition. If I scroll over to something like fan, I have no instances, and that's not because this server doesn't have a fan in it, but because the hardware drivers provided by the server's hardware manufacturer doesn't expose that information to WMI, so I don't actually get to see what's going on with my fans inside the computer. So sometimes you have to expect not to see anything at all. For example, this computer does not have a tape drive. So if I scroll over to Win32 tape drive, I should expect to see no instances, even though I can see the properties of what a tape drive would have if I had one. Now let's look at the documentation. Let's take that Win32 operating system as an example. Oh, I have a better one. Let's take Win32 service. That's something we had already figured out and PowerShell was a little short on. Let's look at the instances of this. Lots of instances. Great. Let's click one. And this has got some good information. Exit code, install date, start mode, auto, start name, local system. So with WMI, I can actually retrieve some of the configuration information that wasn't available to me when I was using the get service commandlet inside Windows PowerShell. So let's go look up Win32 services documentation here. And you're going to hate me, but the best way to do this is not to go on Microsoft's website and start browsing around because that'll take forever. It's to go to Google and type in the class name you're interested in, Win32_service. One of the first 2 or 3 hits is going to be an msdnmicrosoft.com site, and if you click it, that'll take you right to the documentation for it. So this is going to describe the Win32 service class, show me all the different properties, describe what those properties are, and show me these great methods that I can use to change, to create a service, to delete a service, change the start mode, just change anything. Let's see what this will do. This change method will let me change the display name, the path name, the startup name, the startup password. I can use WMI to reconfigure the startup password for a computer. That's fantastic. That's great stuff. So this WMI really is useful, not only because it exposes all this information that PowerShell might not otherwise have access to, but because it lets you do it on remote computers as well. So let's start diving in and actually using WMI inside Windows PowerShell. Now to do that, of course, we're going to need to get the shell running. There we go. Change to the root directory to give me some room here. Clear the screen. The command you're going to use is called getWMIObject. Let's take a minute and look at its help. And it, by the way, does, of course, have an alias, GWMI. GetWMIObject. I need to give it a class that I want. And if I don't want to type the dash class parameter name, I don't need to. If I'm not using the root simv2 namespace, which is the default, I need to tell it what namespace that class lives in. And look, I can specify a remote computer name to connect to instead and specify remote credentials. I can also filter the information that comes back. This is fantastic. Let's just stick with the local computer to start with. Get WMyObject, Win32 service. Okay, great. Remember that little display trick I showed you in the previous nugget? Format list star. That'll work here too, and it gets lots of information for a service. Remember, double underscore means it's a WMySystem thing. It's not for you. Just kind of ignore it. Great information. Start name, state. This is all the information that we were looking at in that Explorer tool. Let's try and filter it. Get all the Win32 service, but only show me, and here's where the single quote, double quote thing will come in handy. Put your WMI filters in double quotes. Because WMI has kind of a different criteria than PowerShell for filtering. I can't just say, show me everything that starts with B. Invalid entry. I have to say where the name is like, and in single quotes I'll put B and I'll put a %, which is actually its wildcard character, not a star. So I've got BFE, bits, and browser. And yeah, that filter criteria can take a little bit of getting used to. The best thing to do is to just go back to that documentation web page and really spend some time reading it. Let's get the one where name equals bits. Notice that by putting the service name in single quotes and by enclosing this entire filter in double quotes, it's easier to read. Okay, so that worked perfectly. So really you've got some good capabilities, and we're going to look at more detail at filtering through this data a little bit later in this nugget, but now you know how to get information from the local computer. Let's try a couple others. Get WMyObject, Win32 operating system. Great. How about we do a format list star? Oh, lots of information. Get WMyObject, Win32 disk drive. Format list star. Wonderful information. So the fact that you can do this with local and remote computers is really powerful. The fact that it has so much information to offer you is really amazing. And the nice thing about working with remote computers in WMI is that it's really no different from working with the local computer. For example, get WMyObject Win32 process. That'll get me a list of processes on the local computer. Wow, that's a lot of information. Let's stick with something maybe smaller. How about that Win32 operating system? Okay, that's a little more easy to read. So to go against a remote computer, just type computer name, or if you don't want to type the whole thing, -comp is usually fine, and specify the name of the remote computer. That's it. Here's something cool though. I've only got these two computers up and running, but I'll specify the name of that one, and I'll specify localhost. That comma-separated list will be treated by PowerShell as, well, as a list, as kind of an array of names, and it's going to go get each one. And so each computer shows up. So you can very easily use a technique like this to go get a bunch of computers' information. Here's a really cool way to do that. Let me go to my demo folder again, and I'm going to create a text file called computers.txt. I'm going to open it in Notepad and type those two computer names. And just for fun, you know what? I'm going to stick each one in here a couple of times. We'll pretend that we're actually talking to more computers than we are. You can have maybe a list of web servers that you always work with as a group, maybe a list of SQL servers, maybe a list of computer names that you've exported from Active Directory users and computers. So back in the shell, you remember how to retrieve or display the contents of a text file? Right? Type, or if you're a Unix person, you might want to use cat. So watch this. Get WMyObject, Win32 operating system, from the computer name in that file. By putting this command in parentheses, I'm forcing it to execute first. So it will read the text file, get that list of computers, and feed that list of computer names to the computer name parameter. It's pretty much just as if I had sat down and typed that comma delimited list myself, although it's important to understand that the text file is not a comma delimited list. The text file is one computer name per line. When I hit enter, it goes to each of the computers and retrieves their information. So that's a really great reason to maybe keep a couple of text files around with the names of the computers that you all sort of treat as a unit. That way you can always grab that list of names out of the file, pass it over to WMI in the computer name parameter, and get a bunch of information from all those computers simultaneously, or take some configuration action against all of those computers simultaneously. When you are using WMI against remote computers, you have to be aware of WMI's security. So let's take a look at that. To do so, I'm going to open a new Microsoft Management Console window, go to Add Remove Snap-ins, and I'm going to scroll all the way to the bottom of this list to find the WMI control snap-in, focus it on the local computer, and add it to the console. If you click on this, it doesn't do anything. If you try to expand the little plus sign here, it doesn't do anything. So you might think it's not doing anything. The trick is to right-click it and hit Properties. Let's look at the security. Just like NTFS or Active Directory, WMI security is inherited, and by default, all these namespaces inherit their security from the root. So we only need to look at the root. I can see that any authenticated user is enabled for WMI, meaning they have the ability to query WMI, but not remotely. The remote enable permission is only available to members of this computer's or this domain's administrators group. So if you're going to connect to a remote computer, you have to do it as a member of that computer's administrators group. Typically a domain admin account will do it for you. If you've logged on and opened Windows PowerShell as a domain admin, then you don't have to do anything other than that. Since I already have the necessary credentials, I didn't have to specify them. However, if you're logged on with an account that does not have that kind of permission on the remote computer, you are going to need to specify a credential. And the way you can do that is to simply specify the username. Here's a little trick though. I want to make sure you don't get caught by this. I'm going to specify my local host as the computer name. You can see it still works just great. Let's say I wanted to specify alternate credentials though. Come up, I'll type the correct password. User credentials cannot be used for local connections. That's not a mistake or anything like that. That's actually the way WMI is built on purpose. So just be aware of that. This is how you specify alternate credentials for a remote WMI connection, but you're only allowed to specify alternate credentials for remote WMI connections. Any attempt to connect to the local machine using alternate credentials will result in that same error. So that's how you can use WMI to retrieve information from one or more remote machines very, very easily. Okay, the last thing I want to cover about WMI is talking about that filtering in a little bit more detail. We're going to stick with the local computer, although this works the same if you're connecting to a remote computer. It's a little bit quicker on the local computer because I don't have to go across the network to transmit my query and then pull information back over. So here's how we're going to do it. Get WMI object. Specify the class that you're interested in. If it's not in the, that's Win32 process. If it's not in the root SimV2 namespace, you're also going to have to specify the namespace. But this is in the root SimV2 namespace. Then dash filter. And then in double quotes your criteria. I'm going to say give me everything where the name is like S. %sign is the wild card for some reason. And it retrieved all those. Here's that command again so that you can see it. So this is how the filtering works. I want to take just a minute and briefly cover some of the major filter operators so that you can kind of construct these things however you need to. WMI actually supports a few different comparison operators. The equal sign means something must be an exact match. If it's a date or a number, you might use greater than, less than, greater than or equal to, or less than or equal to. For strings, you've got the like operator, which you saw me use there. That only works with strings. Now when you're passing a string to WMI, it needs to be in single quotation marks. The like operator uses a % as its wildcard. Numbers do not use single quotation marks. So I might say something like, show me all the disk drives that have a free space of less than 82. And it wouldn't be in quotation marks or anything else. If I were doing an exact match on string, like the name of a service bits, that would go in single quotation marks. Now you may wonder, is WMI case sensitive? Well, honestly, the best way to figure that out is to not look in the documentation, but just to try it out. Let's hop back over here into the shell. Get WMI object Win32 service dash filter name equals, oops, that needs to be a double quote, name equals bits. Okay, it found it. Now let's make it uppercase, bits. Okay, so that particular instance at least is not case sensitive. Experimentation is usually the easiest way to find that information out. So that gives you an idea of how to filter these things down. For example, get WMI object Win32 operating system filter, and I only want the ones where the build number is greater than 6,000. If I was running this against a group of computers, it would show me all of them that were Windows Server 2008, which has a build number of 6001, so it's greater than 6,000. So this gives you a way of sort of fine-tuning and filtering down the results that come back from WMI so that you can just get exactly what you need from it. In this nugget, we looked at some of the ways you can retrieve management information from remote computers, primarily using Windows Management Instrumentation and the Get WMI Object commandlet within Windows PowerShell. We looked at what WMI is and how it works, showed you some ways to explore WMI, how to use WMI from the local machine, how to remotely use WMI, how to specify alternate credentials for remote connections, keeping in mind you cannot specify those alternate credentials for local connections. And finally, how to filter WMI data so that you're really just looking at the information you want. I hope this has been informative for you, and I'd like to thank you for viewing.